So let us continue with the tutorial. The question B is now again relates to dryness fraction and the problems associated with wet steam. For the following data, a process takes place from state 1 to state 2. Alright, so we got a state 1 defined, state 2 defined. Find the properties H, S, V and T at both these states from point 1 to point 2. What is also given is the initial state P1, that is the pressure is 6.5 bar. That means we have been given initial pressure as 6.5 bar, and also corresponding to that, if you see problem 1 now, we have given property 1, that is V1 as 0.16 meter cube per kg. That means the initial pressure is 6.5 bar and the V1 is 0.16 meter cube kg, and the state 2, one of the properties has been given, which is P2 as 2.5 bar. And we have also been told that this process from point 1 to point 2 is a constant volume process, and therefore we know other property also of the point 2, which is at constant volume. So V1 is equal to V2. So indirectly the other property also has been given, while in the next problem you can see is constant pressure. So one has to understand, it could be constant enthalpy, it could be isentropic process, or the entropy can remain constant. So one has to understand what is the hidden value that has been given in the problem. If it is the constant pressure, constant volume, constant entropy, constant enthalpy, any of these properties could be given to you, and correspondingly you will have to determine what is the state 2 now. So the problem therefore is at point 1 we have got P1 as given 6.5 bar, we have also been given V1 as 0.16. At point 2 we have been given P2, and again point 2 we have been given V2, because the process happens at constant volume. What is not known is what is the state 1, where is the state 1 and state 2 lie? Are they single phase, are they two phase, alright, are they in superheated region, are they under the dome, are they subcooled region, or whatever. This is first we will have to make it clear, alright. So because we have been given now in this problem, pressures have been given, P1 is equal to 6.5 bar. Let us now go to table number 2, look at the values, different values that we get at P1 is equal to 6.5 bar, and then we solve the problems. So 6.5 bar is 0.65 MPa. We can go here to the table and we see that we do not have values for 0.65 MPa, but we have got values for 0.64 MPa and values for 0.66 MPa. We will have to interpolate between these two values now. So please write down the values of 0.64 and 0.66, interpolate those values, and I will not show you the interpolation now, I will directly write the values that we calculate for 0.65 MPa, alright. Once we know these values, we will compare the given other property which was V1 and find out state of the fluid at state 1. So coming to the solution of the problem now, we say that this question 1, what we know is P1 is equal to 6.5 bar and V1 is equal to 0.16 meter cube per kg. If I divide this page into two parts, this is state 1 and this could be state 2, and what we know here is P2 is equal to 2.5 bar, and also what we know is V2 is equal to 0.16 meter cube per kg, because this process of 1 to 2 is constant volume process, alright. As I said, we will interpolate the values for 0.64 and 0.66 MPa, and I will directly write the values for 0.65 MPa here. So at 6.5 bar, I will get Vf is equal to 0.001104 meter cube per kg, and I will get Vg is equal to 0.2926 meter cube per kg. What I understand therefore is the V1 value of 0.16 meter cube per kg lie between these two, and therefore we say that Vf is less than V1 less than Vg. So we are in two phase region. Moment we say two phase region, we want to know what is the value of x. So if I calculate x now, I will say for the formulation of V1 is equal to Vf1 plus x time Vfg. I can put the values of V1 as 0.16 and correspondingly values which I have got here and here, I can calculate the value of x1 is equal to 0.545. Alright. When I know the value of x, I can get the values of h1 which is equal to hf1 plus x1 time hfg1. If I put these values, I will get 1815.22 as kilojoule per kg as the value of h. Similarly, I will get the values of S1 is equal to 4.56 kilojoule per kg Kelvin, and I will get the values of U also as 1711.27 kilojoule per kg. Alright. So, these are the values which I will get for state 1. Let us now go to state 2, and we know that state 2 we have got P2 is equal to 2.5 bar, and at from table 2 I will get the values at P2 is equal to 2.5 bar. And what I know is V1 is equal to V2, which is 0.16 meter cube per kg. At P2 is equal to 2.5 bar, I will get Vf2 is equal to 0.00106 meter cube per kg, and Vg2 is equal to 0.718 meter cube per kg. So again we know that Vf2 is less than V2 is less than Vg2, which means that this is also going to be a two phase region. Moment I say two phase region, I should know what is the value of x2. Alright. It means that importantly that this process entirely happens in the two phase region. The point 1 is also in two phase region, and the point 1 and 2 both lie in the two phase region only. I would like to calculate S2 again using the formulation for V2. V2 is equal to Vf2 plus x time Vfg. V2 is 0.16, Vf2 is 0.00106 plus x time Vfg, which is, one can find out the difference between these two, and I can get from here the value of x2 is equal to 0.22. So Vfg is 0.717. So x2 happens to be 0.22. Corresponding to the x2 now, I will get the values of H2, S2 and U2. My values of H2 will be HF2 plus x2 time HFG, which is equal to 1018.4. Value of S2 is equal to 2.81 kilojoule per kg, and value of U2 is equal to 978.413 kilojoule per kg. And the temperature I can get from the table, which happens to be 127.411 degree centigrade, which is the saturation temperature at P2 pressure. Importantly, I would like to show this process 1 to 2 on a PV diagram. The entire process, because it happens on, because it is in two phase region, I would like to locate the point 1 and locate the point 2 schematically on a PV diagram, and that will actually talk everything about the process itself. You know, the point 1 and 2 under a PV diagram will talk everything about this process. So let us plot these points 1 and 2 and draw this process 1 to 2 on a PV diagram. So this is PV. Typically the PV diagram would look like this. So the point 1, this is, let us say 6.5 bar, and because the process is from 6.5 bar to 2.5 bar, this is 2.5 bar, and the process is constant volume. X is 0.545 around in the first case. So this is my point 1, and if I come down vertically, this is going to be point 2, alright. So, this is 1 to 2, the process takes place at constant volume, and this can be shown on a given PV diagram. So, if I go back to the answer, this is my process, P1 is given, V1 is given here, P2 is given as 2.5 bar, I can write other values. The value of x1 was 0.545, the value of x2 is 0.22, which is state 2 here. So, state 1 values are given that we calculated, and the value of state 2 are here, which is the x changes from 0.45 to 0.22, while u changes are given here, h changes are given here, and entropy changes are also given here. So, respective values at state 1 and state 2 are shown, this process as constant volume, and that is why V1 remains the same in this case.